Today's lecture is regarding the time series analysis. Now, what is the need of time series analysis? The time series analysis is used to measure out the effect of values that is changing over period of time. We can consider the example of blood pressure monitoring, heart rate monitoring. You get the output at every fraction of seconds. This is what, and we when we want to do the analysis of this fraction of second data, we are going to use the time series analysis. Suppose we want to find out the global temperature and air pollution levels at every particular 10 minutes, 20 minutes, 30 minutes. So this is what the example of time series data. So time series analysis is the analyzing the time series data with certain tools and techniques. Okay. And this circuit tools and techniques we are going to use for this forecasting purpose. So forecasting is the process of making prediction from the historical data so that we can figure out the future very easily. So to predict the future from the past data is what you're forecasting. So forecasting is a very important element of what your time series analysis. When we are going to study the time series analysis, here we have one characteristic, that is we have the response variable. With respect to time, we that particular variable is changing, and that is what your independent variable. And some target variables are available, that is we are going to predict, that is what your dependent variable. So in this particular time series analysis, there are mainly, this is the example of stock price analysis. So basic structure of time series data is, one is what we have the time stamp. For every particular time series data, we must have what time stamp, at which time particular data is collected. Either it is in the terms of every hour, every month, every year, or we can say every fraction of second, and then we have what element. So this is what timestamp data, and this is what stock price. Now observation are recorded every particular minute. So this is what your independent variable. Now dependent is what, for particular after this is at the time of 1 o'clock. At 5 o'clock, what will be the stock price? So if I want to figure out this particular thing, so this will what by timestamp analysis and the stock price done. So there are mainly four elements of the time series analysis, components of the time series analysis. One is the trend, then we have the irregularity, cyclic, and seasonality. So we'll start with the first type, that is what trend. So trend is what time series data may have a thing that is proportional to the time period, or we can say that trend is the demonstration whether your time series data is moving higher with the time or lower with the time. So your data is either changing very fastly or slowly with over to time within a continuous timeline. This is what your negative or positive fall of the data. This is nothing but your trend of the data. Next is what seasonality. Seasonality is also a component where the time series data will show a regular pattern over an interval of time. So we can see the example that generally generally in the month of May or December, sorry, in the month of May or December, people prefer to go to the hill station. So at that particular pattern, your visiting graph will be higher. So depending on the seasonalities, we are going to what we are going to change the values. The values are going to change. This is what the seasonality. So identifying the seasonality in time series data is important because it will be the development of a useful time series model, at which time my particular place will be more crowded, so I can have the different attraction for that particular targeted people. So tools that useful for detecting seasonality are time series plots and statistic analysis test. Now here we can observe that. See, after every particular interval, you have some peak value. After every particular interval, we have the peak value. Then cyclic. Cyclic is the component which the time series data repeats after every some interval of time. So after interval of time, electricity demand per week, if we are going to plot. So if this is what the demand of per 2 weeks is repeating. See, this is repeating here, again this repeating here. So this is what, this is the example of cyclic. Now, next one is what we have the irregularity. So irregularity means what? Unexpected situation events that with spikes in a short interval of time. So what we can observe in irregularity, suppose we have the suddenly we have the we can see take the example of we have the flood. In the flood situation, suddenly the demand of what? The demand of water, or we can say in drought, the demand of water will be increased. In the case of flood, the demand of food packets will be increased. This is what depending on the situation. Suddenly in COVID, suddenly it is increasing of what? My oxygen level. So this is what oxygen we needed suddenly. This is what irregularity, that is not expected by the normal people, that is irregularity. So here we can see the, and we can compare the components of time series. Trend is what? For the fixed time interval. Seasonality is again time interval is fixed, but cyclic it is not fixed. It is continuously. Again in irregularity, the time is not fixed. Here trend duration will be long also, and for the short time also. Short time also, for short time means what? We can say that for 4 months my cell is going to increasing. For 1 year my cell is going to increasing and increasing, either decreasing. So in very in very in only one direction, either in positive, either in the negative, my values are increasing or decreasing. This is what trend. Seasonality means what? As I told you, swings between up and down. Repeating patterns, that is what cyclic, and irregular is sudden spikes. Okay. So to predict the trend and seasonality is very easy, but cycling and irregularity it is very difficult. It is challenging task to predict something. Today I cannot predict that after 3 months there will be flood and there will be the demand of the food packets like that. So these are the components of time series analysis. So time series analysis again classified into parametric, non-parametric, linear, non-linear, univariant, multivariant. So we will see some uh, Python code for your particular analysis of things. So here I have the, suppose to analyze the time series data, I have used one case study. That case study is, my case study is what? Train data keywords such as diet and gene. What data set I've considered? I've considered the data set of what the resolution taken by different people at the starting of the न्यू ईयर के टाइम पे हम लोग क्या लेते हैं? रेजोल्यूशन लेते हैं. So diet and gym, this two type of resolution I have observed most common in the that particular resolution, and I'm going to find out what, using the real life case studies, I'm going to find out the relation between the diet and gym. So in this thing, we are going to import the packages that we need, that is numpy, pandas, matplotlib, sns. Now this is my data set. So if we observe the data set, here we have the month, that is some head means what? First five values of your data set, that is 1 2 3 4 5. So first five values will be like this. uh, Diet 100% preferred diet, gene 31, finance 48%. Then second month of 2004, then third month of 2004, 4 month of 2004. Likewise we have what? We have the different distribution of what? Your data. This data indicates what? At the starting month of 01, first month of January, 100 people are interested in diet, 31 people are interested in the gene, and 48% were interested into finance. As the time moves on the second month, the diet will be reduced to 75, gym will be reduced to 26, and the finance will be increased to 49. So this type of data set we have. Now I want to find out what, how the gene and diet are related to each other using time series analysis. So now very first step is what? I'm going to analyze the data. So to analyze the data, first thing is what? How many columns I have, how many rows I have. I have 168 entries, and type of this particular column is month is of type object, diet is of type integer, gene is type of integer, month is of type integer. Now, very first thing is what, instead of this fancy name of column, I'm going to rename my column. So for renaming the column, I have the function that is df columns. So my name will be changed over here. So here I have data, month, date, time, and all. Then I'm going to observe what, month wise data. So I have index. I want to analyze month wise. So my index will be month. And now I want to change what, data type. So here, if you observe for the month, your data type will be object. So I'm going to change into which, date and time format, because I want to analyze time series. Main first step of pre-processing, we can say, for time series is to convert your timestamp into date and time format if it is not in the date and time format. So I have converted into the date and time format, df.month, and then this is what, month wise, and I have set the index because I need month as an index. So I have set month as an index. Now I'm going to plot the year wise data of every particular thing. That is what, three columns I have: diet, gene, and finance. So blue will indicate the diet, gene, orange will indicate the gene, and finance. So this is the normal distribution without any pre-processing. Only we have changed what, timestamp. Now I want what, I want to analyze the diet, because I need what, I want to relate diet and my gene. So first I'm going to analyze the pattern of my diet. So for that purpose, I have written diet, and then I have plot the data. So my this plot of data. In this particular plot of data, now what you can observe, in this particular data, you can observe that there is a seasonality. Means in each January, we can say starting of the month, in each January there is a big jump. Also there seems to be a trend is present, because slightly up, then down, then again back, then again down. So in other words, it look like that there are trends and seasonal components present in my data set. Which components are present? Trend and seasonal components are present in my data set. Now I want to identify the trends by using time series. So there are several ways to think about the identify the trend into the time series. The very first thing is what, to find out the rolling average. So very popular way is what, to find out the trend is rolling average. In rolling average means that for each time point, you are going to make the average of points. Matlab, you are going to make the average of points from either side. If it is positive value, you are going to take the rolling average of positive side. If it is negative value, you are going to take the rolling value of negative side. And by specifying the window size. Now, window size means what? Here we have 12 months. So we have taken the window size equal to 12. So likewise, your application, you can decide the window size, and then we are going to find out the rolling mean to analyze the trend. So what is the function for that? Diet is in which I have stored the data. Rolling is the inbuilt function in which I'm going to pass the parameter, that is window size 12, and then the mean of that, and then I'm going to plot the data. So this is what my, this is, you can observe the trend. So in this particular trend, in particular chunk, you have observed that you have observed that you are looking for which trend you are looking for. Means January increasing, then decreasing, again increasing. So what we need now, same if I want to do for the gene. So for the gene, again I'm going to find out the rolling and then mean. So here you can observe that in gene, you can observe that here what, here we have what, increasing, but now this is what, only increasing component. But now we need what, relation between diet and gene. So I'm going to combine both. I'm going to create one data frame, that is df underscore rm. I'm going to concate my diet part and the gene part. Both of the things I'm going to concate in one particular frame, df.rm. and then I'm going to print df.rm. I'm going to plot the graph. Then I plot the graph. So now you can observe that. What you can observe that you have plotted the graph. Now we can trends are identified. So now we think about the seasonality. So which is repetitive nature of your time series. So we can say that seasonal components of the time series of your data is to remove the trend from the time series analysis. मतलब मुझे I want to remove what ट्रेन सो मुझे अगर ट्रेन रिमूव करना है so I can subtract my train from the rolling mean. What I need to do is I need to subtract my train from the rolling mean. So here we are going to use first order differentiating. So first order differentiating is where you look at the difference between your data patterns and your one data pattern and your one data point. So we are going to perform what first order. So diet dot difference. When a difference, when I'm going to plot, so here you can more precisely you can observe the difference. So see, you can remove much of the train. We have removed much of the train from the data, and here we can really see the peaks. Here we can see the peaks very clearly. So this is what we have done. What here we have performed what first order differentiating. After third order differentiating, what I need is a time series is periodic and autocorrelation means every 12 months the pattern is changing. So when I want to relate this particular thing between diet and gene, so I need what coefficient. Coefficient means what correlation between these two particular things. So correlation means what that we have studied. So when I'm going to find out the correlation of this particular data set, so you can observe that diet and gene, this is what minus 0. So the correlation level that we are going to consider is what negative correlation. But here we can observe that in the pattern that it is not every time negative. Sometimes when your diet will decrease, your gene will be increasing. So now proper analysis of this particular correlation. Now I am going to do what? This is the correlation. This means what? Diet and gene are oppositely correlation, but this is not the fact. So what I am going to do is now I am going to do after finding out the correlation. So remember that you have a seasonal and trend component. So from the correlation coefficient, diet and gene are negatively correlated. So when we are looking at the time series, it is not like so. The actual correlation is what capturing of both. We have to capture both. So what we can do is we are going to find out the differentiation of what differentiation of the our this particular data set. So we are going to find out df.diff complete data set. Now we have what the differentiate of complete data set. But now I want only diet and gene. So for this particular diet and gene, I am going to plot what autocorrelation. So autocorrelation is the time to plot the autocorrelation of the diet series. So you have the lag and y-axis. On the x-axis, you have the lag, means what? Where it is lagging the data, and in the y-axis, you have the correlated the time series. Matlab, at which particular time release it is correlated or where it is lagging. So here you look at the picture. So what you expected is at the 12 months, the time series is correlated with itself by 12 months. 12 months के time interval पे it is what changing and changing. So this is where at what particular time it is lagging, at what particular time of increasing. So if you include more lags in your axis, you will see that is 12 months. अगर तुम लोग यहाँ पे legs include करते हो, you can have the more features. So the dotted lines in the above plot, it actually tells you about the statistical significance of the correlation. So you can say that diet series is generally autocorrelated with a lag of 12 months. Lag of 12 months. मतलब जैसे ही 12 खत्म मंथ खत्म होते हैं वापस क्या होता है वो अपना पिक पकड़ता है वापस क्या होता है उसका पिक पकड़ता है. So you identify that seasonality for this month is 12 months of repetition. So what conclusion we can say that ki 12 months is what repetition period for my seasonality. So you have covered a ground level of time series analysis. Here you can check out the trend of diet and gym by looking at the particular uh, particular data set. So now you can more you can elaborate using the finance also, and you can do with the same finance also. So this is all about the time series analysis, and different models we have, like ARIMA model to make the time series forecast. When I want to do forecast, when I in your syllabus you have time series only, but when I want to do the forecasting of something, so for that particular forecasting, you have the model that is ARIMA model. In this particular ARIMA model, so ARIMA stands for autoregressive integrated moving average. So here you are going to machine learning mastery, you are going to use for ARIMA model, and then you are going to forecast something. So this all about what today's lecture. Thank you.